Hey guys, Mr. Bullock. This is probability models, and let's go ahead and begin. And right after this, take a look at the one that's probability rules. It follows directly after this one here. They're both pretty fast, you guys. Probability models. We're going to see this box on page 336. And sample space is just everything, you guys. 100% of your sample, what you're doing your study on, is your sample space, and the event is just anything that happens in that sample space, and then probability models is a mathematical computation that we'll learn in the next lesson on probability rules. Okay? All right, so let's go ahead and try one. Rolling dice. So here's an example on page 336 and 337, example 6.3. Roll two dice is a common way to lose some money in casinos, and so there's 36 different ways you can roll two dice. And so it's going to be recorded as the ordered pair, first dice, comma, second dice. And so this next figure shows the 36 different ways. Okay, so check this out. You can get a 1 and a 1. You can get a 1 on the first dice, a 2 on the second dice, a 1 on the first dice, a 3 on the second, a 1 on the first, a 4 on the second, a 1 on a 5, and a 1 and a 6. And you can start with a 2 on the first, a 1 on the second, okay, all the way down to a 6 and a 6. So there's 36 different ways to roll two dice right here. So rolling a 5, excuse me, you can get, there's 4 different ways to roll a 5. You can get a 1 and a 4, a 2 and a 3, a 3 and a 2, and then a 4 and a 1. Okay, there's those 4 different ways to roll a 5 out of the 36. Okay, gamblers are often concerned about the number of pips on the up faces. That's just the numbers that are facing up, you guys. So the sample space for rolling two dice is you can get a, and this is just the sum, you guys. You can get a sum of a 2, a 3, a 4, all the way up to a sum of a 12. So this is the total sample space of rolling two dice and looking at the sum on the top of them. Okay, we're interested in the sample space on this lesson. All right, so picking a random digit gives the sample space 0 through 9. Okay, there's 10 different ways you can pick a random digit. Notice digit is singular. Okay, flipping a coin and rolling a dice. So here's a tree diagram that you can see how to flip a coin and then roll a dice. Okay, so this is a figure or example 6.5 on page 337 and 338. Okay, so here's flipping a coin. So you flip a coin first. You can get a heads or a tails right here. And then I'm going to roll a dice now. So say I got a heads on the first flip. I can get rolling a dice. So 1, 2, 3, 4, 5, 6. And same down here. If I roll a tail, I can get a 1, 2, 3, 4, 5, 6. So what happens is you get 12 different outcomes right here. You can get a heads and a 1, a heads and a 2, all the way down to a tails and a 6. All these, so this would be my sample space right here. Right there, the 12 different outcomes for the sample space. Okay? All right, so if you flip a coin, okay, we're going to have to do this manually. I want you to, this is not in the book, so it's real easy. So list the sample space, and I'm going to do a tree diagram, you guys. So here's the first flip. You can get a heads or a tails. Now say you get a heads on the first flip, and on your second coin flip, you can get a heads or a tails. So I can get heads heads or heads tails. And then down here, here's the other 4 if I got a tails. I'm sorry, the other 2. You can get a tails heads and a tails tails. Okay, here's the third flip. Okay, the third flip I could get, doesn't matter if I got a heads on the first, a heads on the second, I can still get a heads or a tails on the third. Okay, and so on, and so I can get that, and then there's the other 4. So here's the sample space right here, you guys. I can conceivably get a heads, heads, heads. I can get, notice I'm color coding them in red where I got the heads, heads, heads. Okay, I can get a heads, heads, tails. I can get a heads, tails, heads, a heads, tails, tails, and so on, and all the way down. And so there's my sample space right there. Okay? All right, so if we flip the coin 4 times, this is section F, and then here's another way to list the 4 times. You don't have to do the tree diagram, and so this is example 6.6 on pages 338 and 39. And they list them like this. One way is to list all the ways you can obtain 0 heads on flipping 4 coins. Then list all the ways you can obtain 1 head, and then 2 heads, and then 3 heads, and then finally 4 heads. And this is how they did it. Okay, I don't care if you do the tree diagram or this way right here. So see, there's only one way to get 0 heads if they're all tails. There's 4 ways to get 1 head. There's 6 ways to get 2 heads, 4 ways to get 3 heads. Notice, you guys, to get 1 head is the same as getting 3 tails. to get 3 heads is the same as getting 1 tails. And to get 4 heads is the same as getting no tails. So just watch wording and you'll see that how that will help you later, you guys. Okay, so if you pull a card from a standard 52 card deck and then you pull a second card, it depends on if you replace the first card or you don't replace the first card. If you replace the first card, then the second card is completely independent of the first card. But if you don't replace it, say you pull a card out and you leave it out, then the second card is totally dependent on which card you pulled out on the first card.